Hello students, today we will be going over Chapter 11 Wrap-Up. This is page 231 in your blue packet. Create the scatter plot. Describe the association. So here we have our answer bank: positive linear, positive exponential, or none. So our association, we have 5 different choices. There's one of your 5 choices. There's all of the 5 choices there. So now all we have to do is plot the points. 1, 10. So hopefully you could see that down there. 1, 10 right here. Again, x first, y second, 3.26. We're going to have to estimate in there, right there. 5.5, 13. 5.5, 13 is just going to be below 15, so right there. 7, 15, so 7. 15 is right in between, right there. 8, 25. 7.5, 40. 9, 53. 8.5, 78. 9.5, 100. And 10 and 90. Okay, so what I do is I try and draw a line that will include or go between most of these points. So if I do that, I would somehow draw it something like this, right? And you say, what type of graph is that? Well, it's not a straight line, it curves, so it can't be linear at all. So is a positive exponential or negative exponential? Okay, so it's not, our negative exponential would be going down and curving, positive exponential. So that's our association, positive exponential. Okay, all right, I'm going to let you do the rest on that page. I'm going to go on to the next page. And it says, use the model to answer the question. I'm going to jump to number 6. This is the amount of energy. It says, the amount of energy consumed by a house is related to the temperature and can be modeled by this, okay? If we wanted to say if this was linear or exponential, what would you say? Okay. I would have to say that it is linear because the x is not in an exponent anywhere. And is it positive or negative? Well, we look at the slope. This is a positive slope. So if you needed to know, it would be a positive linear equation. Next, we need to predict the temperature if 35 kilowatt hours of energy was consumed. Now remember, X is the average daily temperature. That's not what they give you. They give you Y, the amount of electricity consumed. So we need to make sure we plug in 35 in for the Y value, not for the X value. So 35 equals 0.472X plus 5.1. And again, now we have to solve for our X value. Now, if they give you the the X value, the temperature, then you plug that in and you can figure out how much energy would be consumed. But for this, we have to put it in for Y value. And then we use our problem solving skills. And I think that's going to be 29.9. And then to solve for x, again, divide by what's in front of x. And what should we round to? The nearest tenth. So if we take our handy dandy calculator and we say 29.9 divide by 0.472. That's a big old long number. We're going to round to the nearest tenth, so we look at the hundredth. That's a 4, so since it's not 5 or higher, I'm going to say 63.3 degrees. And I think it's in Fahrenheit, so right there would be our final answer. Okay? All right, we're going to go on to the next part, to page 233.